Welcome back to another lesson of Math 8. I'm your host, Mr. Quilter, and this is Unit 3, Lesson 6. We will be talking about more linear relationships. Today we are going to talk more about the relationship between two variables and more about what it means to have a slope and what it means to have what we call a vertical intercept or the y-intercept. We also want to recognize that linear relationships have to have a constant rate that gives them a straight line or a straight or values that cause the line to show in a constant pattern. We're going to start with that by looking at these images here on the first part of lesson 6. We see three images. I've colored these to match what we'd see in the book. This first little yellow box corresponds with each of these other these other two boxes. The blue with the blue and the red with the red. So if your pattern continues growing in the same way, how many tiles of each color will you see in the fourth and fifth diagrams? And then finally in the 10th diagram. Go ahead and take a minute to answer that. All right, given our pattern that we see right here, we see a grid that is a 1 by 1. On our yellow, possibly see that we're going from 1 square to 4 squares, which could be, maybe 4 times greater. And then we can look at our next pattern and we see 3 by 3 on the array, which that kind of debunks our case of 4 squares more. So we need to start thinking more about this side of it. Well, maybe this one is a 1 by 1, and this is a 2 by 2, this is a 3 by 3, which we see as perfect squares. What we could recognize from this one is that we have patterns of the yellow would be 1 squared, 2 squared, 3 squared. And what that could tell us is that the pattern would continue that way of 4 squared, 5 squared. And so we take with these diagrams, the fourth diagram would show us 4 squared, the fifth diagram would show us 5 squared, and then the 10th diagram, we put a dot, dot, dot there, tells us the pattern continues. The 10th diagram would be 10 squared. When we look at the blue, let's look at the blue and see what's different about the blue. There's 3 units tall, and then we see it doubles to 6, and then we see 3, 6, and 9. We see it triples. So maybe when we're talking about the blue, we could talk about moving in our pattern. We're seeing it as a pattern of 3, 6, 9, and we see that there's a constant pattern here. The first term is 3, the second term is 6, the third term is 9. Perhaps if I looked at the blue as a pattern in a table, I could see that the first image has 3 units, the second has 6 units, the third has 9 units. That would tell me that the fourth, I see a constant pattern developing here that I'm just increasing by 3 blocks each time. And so I could make my fourth one say that this will be 12. The pattern will continue. 5 plus 3 would be 15. And I could continue to see that this piece would be that we're talking about the 10th diagram, I can see that 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So that means 10 times 3 would be 30. Finally, with the red, we see a pattern that's developed of 1, 2, 3. If this pattern were to continue, then perhaps in the fourth diagram, we could probably see that in the table as well. In the first, we have 1 and 1, 2 and 2, 3 and 3. So it seems reasonable to say that we have 4 and 4, 5 and 5 for the fourth and the fifth. And then the 10th, it would be reasonable to assume that that would be 10 and 10. These are all just a few of the pieces that we can look at with a few different ways that we can look at this. When we're talking about how many tiles of each color will be in the nth diagram, what we're after with this, when we're talking about the nth diagram, is writing a rule that could describe a rule or an equation that can describe how that tile is changing. In this equation, what we're looking at for the very first one, we're seeing that the rule is that the side length is being squared. So if we said let S be side length, so this is for yellow, let S be side, then Y equals, actually maybe we'll make that an x just so we're consistent. Then y equals x squared. Okay. If we're talking about the blue, y, we could say that x is the number of term. Let x be number of diagram. Well, what we started out with here is we could say that the first term right here, we started out with 3, and then we increased to 6, then we increased to 9. For every single diagram, we increased by 3. So we could see that this one is y equals 3x. 3 times 1, 3 times 2, 3 times 3. The y coordinate is always equal to 3 times as many as here. When we look at the red, we could say the same things here, x be the number of diagram. And then this one, when we talk about the output, well, we see that the output y is equal to the input x every single time. So 3 possible rules, 3 possible outcomes. Give those a rule.